Have have no fear of perfection. You will never reach it. A very warm good afternoon to one and all because it's a very cool day. I, Dr. Reena Meshram, on behalf of Postgraduate Department of Chemistry and IQAC Nabira Mahavidyalaya Katol, welcome you all on the sixth day of our 10 days national lecture series. On this sixth pretty day of lecture series, we are privileged to have the eminent speaker, Professor Vasudev Gurnule, and Sir is going to deliver a talk on an overview of elastomers. Welcome you, sir.
Thank you.
Now, to give the brief introduction of our today's guest, I would like to request Dr. Nilesh Gandhare, convener and assistant professor Nabira Mahavidyalaya Katol, to introduce our today's guest. Over to you, sir.
Thank you, ma'am. Good afternoon, one and all, and happy Republic Day. Today, this task of introducing our guest of honor and speaker is a great privilege. I know this one is difficult, but the thought that he is a man of virtue and simplicity. I feel elated to introduce him to everyone today. Dr. Gurule sir published so many papers in research journal. Dr. Gurnule sir obtained his PhD degree in 2000 on polymer chemistry from RTM Nagpur University, Nagpur. Dr. Gurnule sir is presently working as a professor in Department of Chemistry, Kamla Nehru Mahavidyalaya, Nagpur. He has deep understanding of biodegradable and conducting polymers and extensive experience of research and teaching. Dr. Gurnule sir published more than 200 research papers in national and international reviewed journals and presented more than 1000 and presented more than 110 research papers in national and international conferences. He is a reviewer of 38 international journals of elsewhere, John Wiley, Springer, Marcel Decker, Bentham, RSC publication, having impact factor more than 2.0. He has received CRSI Best Teacher Award 2011, Distinguished Scientist Award 2016, Above International Outstanding Research Award 2016, Best Teacher Award 2017, Best Research Paper Presentation Award for 7 research papers in conferences. He has published more than 360 science articles in daily newspapers for the peoples of society aimed to popularize the science. He has successfully guided 26 students for PhD degree and 8 are currently registered for PhD with him. He has successfully guided 21 MPhil students for their dissertation work. He has successfully completed 3 research projects of total amount 46 lakh 870 rupees of UGC. He is author of 32 books, 11 book chapters, 7 of which are of international level published by Apple Academic Press, Canada, elsewhere. He is the Secretary of Society for Promotion of Material Science, Nagpur. He is the Secretary of West Zone of Association of Chemistry Teacher, Mumbai. He is a life member of more than 12 various academic societies. He is recently honored by Best Researcher Award by Rashtrasanta Tukaduji Maharaj, Nagpur University, Nagpur on 5th September 2018. Recently, ISCAS prestigious Silver Medal Award received in 11th ISCAS National Conference at Nagpur, 20 December 2019. He has delivered more than 60 invited talks in national and international conferences. He has organized 7 national and 11 international conferences for the researchers of India and abroad. He has visited countries like Malaysia, Singapore, Indonesia, Thailand, Nepal, Taiwan, Hong Kong, Bangladesh, etc. Dear participant, please join me in welcoming Dr. Gurnule sir, who is going to talk about an overview of elastomer. Dr. Gurnule sir.
Thank you, Nilesh. for your introduction. And before going to start, first of all, I thanks the organizer, particularly the principal of the college, Dr. Naveen sir, and the coordinator, Dr. Nilesh Gandhare, PG coordinator of Nabila Mahavidyalaya, and all the team of the chemistry department. This is the wonderful activity we have carried out by organizing this lecture series. One more thing that I want to tell you that this year in 2022, GWB, that is IUPAC, organized GWB, that is the Global Women Breakfast, and the theme is the empowering diversity in the science. So those are interested, they can register their college or institute on the IUPAC GWB website for activity, and which is held on the 16th February 2022. This is the already more than 200 institute all over the world from 60 countries have registered their institute for the organization of this activity on 16th February. Okay, so those are the participant may be there, and your institute also, they can register. There is a on the website GWB22, go through that. There is a column 1, register yourself, and some instructions are there. We have to follow simple instructions. Okay, this is one thing. Another thing, before going to start, as we know, in 2019 already we have celebrated International Year of Periodic Table in the chemistry. Okay, now United Nations have declared from 1 July 22 to the 31st June 23, this year complete, from July to June 22 to 23, this year have been declared celebration as a that is they are celebrating International Year of Basic Sciences in Sustainable Development. They have been just declared, and all over the world the organizations or institute or colleges or university organizing some activity related to this seminar, organization of seminar, conferences, webinar, or any debate competition or any other activities related to the basic science. So this is not limited to the chemistry, but now it is a broad sense. What is that? As International Year of Basic Sciences in Sustainable Development. So we can organize also related to that, but from the 1st July 22. Okay, so thank you. I'm sharing the screen. Nilesh, am I audible now?
You are audible, sir. Yes, sir.
Okay. Is the screen visible?
Yes, the screen is visible, sir.
Also moving?
Yes, yes, yes. It is moving, sir.
Okay. So today's title of my talk is an overview of elastomers. As we know, what is elastomer? It is a polymer having elastic properties, and detail about this elastomer rubbers we are discussing in today's part. And as we know, this presentation includes different aspects. What is the polymer, elastomers, introduction, classification, applications, properties of these synthetic and natural rubber. Processing is also there, and reinforcement by different fillers, and property. So so here, this is the outline of today's presentation. And as we know, what is polymer? Uh, the word poly means many and mer means molecule. We can say that polymer are one of the important substance which have great impact on our daily life. And there are different types of monomer we can take for the polymerization to form the polymer as per our requirement. And monomers are the small unit which is repeated in the polymer chain and having high molecular weight. In addition to that, oligomers are also there, which is also a low molecular weight compound, and generally it contains 5 molecules. And now, as we know, polymer is a macromolecule, and there is a difference between high molecular weight compound and polymers. Polymers are also the high macromolecules having high molecular weight, but the difference is that as compared to the macromolecules, there is a repeat unit of the monomers. And there are a number of applications of this polymeric material. And this slide shows the different application of this material. And we can use this material for this bottle, for reagent, for covers of the medicine, tablets, or this bicycle. So many are shown here. Different applications, different part of this car, this in cosmetic also, for building, for the coatings of buildings, and some materials are there which is made up of the this type of polymer. And as we know, polymer are well known and recognized from the simple bag to the very complex sophisticated material. And therefore we can say that there are a number of applications of this material. And fuel cell membrane are producing electricity, reinforcement material for space shuttle, like that. So, and we can see that there are so many articles which are the gift from scientists to our society. That is the main man-made fibers. What is that we can say is the polymerized product. And also we can say that this material have brought the revolution in textile industry, and because of that, nylon, resin, or the natural synthetic rubbers are the gift from scientists to our society. And there is no doubt that polymeric materials are the is a part of our daily life, and without them, the complete world is a totally different. So this is the applications of this material. And in case of polymer, there are also some advanced polymers, which is also known as the smart polymers. And these smart polymers can be used for different purposes. And particularly, we can say that for what is the for separation purifications, for artificial muscles. So these are the areas where we can use this material. And there are high performance polymers also, which include plastic, fluid, membrane, smart, hydrogel, and elastomers. That are the design as per the need of the society. In this elastomer, I'm going to give detail about the what are the process, what are the compounding, what are the
Sir, sorry
applications.
to interrupt you. Sorry to interrupt.
Yes.
But there is on your screen, we found two bands, which is where there is a heading. There is, we found one black band, and on the extremely right side, because it opaque and it मतलब ये दिख नहीं
It's
रहा
okay
है
now.
उसकी वजह से. Yeah, but there is one more on the heading which interrupt the all the
Yes,
things
yes,
on the
yes.
screen.
Okay, okay. No, the panel is there na, on the top. How
Yeah.
can it be removed?
Sir, just exit from the presentation mode and try to remove. Maybe it is like that.
Okay, so I have to stop this presentation again and we have to share, na?
Yeah. And from same slide, we can continue.
But again is there.
There may be the option of cut, sir.
Yeah, try to select that panel.
Select and cut.
Yeah,
Or
and delete it.
Now it is in the bottom. Okay.
Yes, yes.
Yeah, it's okay, sir.
But again, it show at the bottom, sir.
It can cause,
Disturbance.
yeah. How to remove that panel? No option is
Now,
there.
what are the options there, sir?
How this? How can we remove? It can move. It is moving.
What are the options there when we click on these boxes, sir?
More options in that.
Or and
No options are there, sir.
No. Disable annotations further. Show name of, I don't know, show video panel. Yes. Okay. Now it's okay now.
yes, one more, sir. At
No, it's okay then. If
It is
it
now
will
okay.
take,
Yeah,
maybe
it,
it will take
it
a
is,
time. Yeah.
no.
Yeah.
yes, yes.
So
It is
let it
removed.
be, sir.
Okay. The panel is now is not there. Okay.
Hmm.
Oh,
It's okay now.
Yes.
okay.
Sir, it is
The
okay.
panel is visible now.
Yes, sir.
Yes.
Okay.
Yes, sir.
So what is now? These smart polymers are there, and there are high performance polymer which include plastics, fluids, membrane, and some smart hydrogel, and also elastomer, having number of applications. So here is shown what are the application of these smart polymers. Okay, now. So here I want to tell you that actually we are working on this elastomer and also natural rubber and synthetic rubber, and the audience can also do research on this part because there is a lot of scope to improve the properties of the natural or artificial rubber, and by using different nanofillers. And this is the main part that I have selected this topic for this presentation. So there is a lot of scope and new things are there, and we can improve the properties of the elastomer or the rubbers. So here this slide shows nanomaterial in the polymer matrix, and as we introduce the some nano metal oxide or nanofiller in the polymer matrix, then there is an enhancement in the properties, and the enhancements means the load when this material used, then they show their dispersion in size, shape, orientation in nanoscale phase, and because there is an interaction between polymer matrix and the rubber. And because of that, high surface to volume ratio is there, increase the chemical resistivity, and reinforcement is also there. And because of that, stability, or in short, we can say that this material can show multifunctionality. And this multifunctionality of the material can be achieved or can be studied by making the nanocomposite. So nanocomposite of this polymer have multifunctionality, and they show enhancement in the properties, and these properties have been shown here in the slide. As we know, polymer have played an integral role or important role in the advancement of drug delivery technology, or by improving some properties. So here this slide show what are the properties. They show the enhancement, that is increase in diffusion constant, increase the durability, increase the toughness, increase the thermal stability, and also biodegradability is there. So this is the important part of this nanocomposite material. This slide shows some variation in the properties and applications of this nanocomposite material. Once we make the nanocomposite by using nanofiller with this rubber, then they show the enhancement. And for high performance material, we can say that the energy storage bio-based polymer can be used for fire behavior and fire retarding mechanisms. That also we are going to discuss. And now in case of biomedical, bioactive glass, fiber, biomedical and dental applications are also there. So in case of the polymer for drug delivery, an important part of this here in case of nanofillers or nanocomposite and polymers have played an important role for the advancement of the drug delivery technology by providing the controlled release of therapeutic agent in constant doses for the long periods and releases both hydrophilic and hydrophobic drug like that. So these are the some part of this material of nanocomposite which can be used for different purposes. Can be also used as electrocatalyst because as we know electrocatalyst is a catalyst that participate in the electrochemical reactions and enhance the durability of the because it is a bio-based electrocatalyst and also as a sensor electrode material. These are the applications of this polymer nanocomposite. Now, as we know, classification of polymer, we know what is polymer, what are the applications of polymer. Now, the polymeric materials are mainly, we can classify on the basis of their source, origin, or structure or properties. So, based on the sources, these polymers are natural or synthetic or semi-synthetic polymers. And what is the natural polymer? That is, we know natural polymers which occur in nature and generally they are the obtained from the sources like plant or animal. And common example is the protein, cellulose and starch and rubber. So we are here mainly interested for the rubber. And again, rubber are of two types, rubber, natural rubber and synthetic rubber. So these are the natural polymers. And here this slide show some examples of natural polymers. Cotton from the plants is a natural polymer and is used for making clothing. That is natural latex obtained from the rubber tree, which is the latex obtained from tropical plant, which is shown. And also some other examples have been shown here. Rubber bands, rubber can also be used to make the tire. So this is the main applications. And as we know, out of 100% rubber, 65% rubber are utilized, are used in the rubber industry. And the remaining rubber can be used for making different articles related to this household and other aerospace materials. So this is the important polymers have number of applications and we can improve the properties of these polymers or rubber. Synthetic polymers is a man-made artificial polymers can be synthesized in the laboratory and also commercially they can also be synthesized in the industry. And some example of this type of polymers are, as we know, common examples are there, polyethylene, nylon fibers are the common example of synthetic fiber which are synthesized in the laboratory. Semi-synthetic polymer is also there, natural and synthetic. Between that, semi-synthetic polymers are also there. We can modify the natural polymer by adding some some material and artificial in the laboratory. Such type of semi-synthetic polymers can also be modified, and these polymers can be controlled in a controlled environment and have number of importance of this material. And semi-synthetic polymers are generally the vulcanized rubber because sulfur is the cross-linking material which can improve the properties of the rubber, and cellulose acetate rayon is another example. So semi-synthetic material also have the importance. Now based on the structure of the polymer, here is shown linear, branch and cross-linked polymers. And in this case, what is linear polymer? So here is the structure is shown. linear structure is there. Only one long chain of these materials are there. In case of branches, there are different types of branches. See now, long chain is there. Also, some branches have been shown. And in case of cross-link or network type structure is shown, here is the cross-linker can be added. And because of that, this type of cross-link or the network type polymers are there. So the three different types of based on this structure. So this is the linear polymers. Ethene we can take and form a long chain and forming polyethylene. So this is the repeat unit, which is repeated and forming a long chain, which is a linear polymer. In case of branch chain polymer, here is shown, see, this is the long chain of carbon and along with, here is another branch, second branch is here. So in this way, branchings are obtained or shown by joining the monomers together in a long chain of the polymers. So this is a linear and second is the branch chain, and the cross-link polymer is also possible. An example of cross-link polymer is the melamine or bakelite. This is the phenol formaldehyde type of resin, and this is the phenol and formaldehyde. By polycondensation, we get this type of network structure, and this structure is shown bakelite. And as we know, bakelite have number of applications. It is a color resistance or chemical resistant material is there. Therefore, it can be used on the top of the chemical laboratory because so many chemicals are here when we are doing the any reactions or they in that case. So what is so to avoid the surface of the table to damage, what is the generally these sheets are using in the laboratory. And this is the network structure of bakelite shown here, second figure. See the how the network cross-link structures are being shown here, and this is simple bakelite resins and can be used as an insulator. So three types are there depending upon the structure of the material. The polymeric material can also be classified into molecular depending on the molecular forces. There may be a thermoplastic, thermosets, elastomer, and fibers. So thermoplastic is the material shown here. This type of structure is there. Elastomer have elastic type properties, and thermosets, once it is set, cannot be make it reconverted. So thermoplastic means it is when we apply the heat, it becomes a soft and can be molded as per the requirement. So here, what is thermoplastic? So these are the polymers become a soft on application of the heat and can be molded as per our design. And because of that, this thermoplastic material can be used for making the television cabinets. We can make we can mold as per the requirement. And polystyrene can also be used as a thermoplastic, and which is kept in the, as we know, in the helmet inside the spongy material is there. That is the polystyrene material. And so polyethylene, polypropylene are the examples, and styrene, polystyrene are the thermoplastics. So important part is that they become soft by the application of the heat and can be molded as per the requirement, as per the need. And thermosets are there. Once it is set, cannot be reconverted back. So these are the polymers, thermosets. These polymers also have their long chain, individual chain bonded covalently during the polymerization, and by application of the heat. And once this material set into desired shape, then cannot be changed. So there is a mechanical deformation or heat softening or solvent attack is there. Because of that, structure is shown here. Cross-link resin bakelite is an example of thermoset. Once it is set, then there is no any change. So these are the two important material. Elastomer is the elastic type polymer. Elastomer is nothing but the polymer and have the elastic properties, and which can be stressed then like a rubber because of they have weak intermolecular forces in the chain. They have cross bonds. So here is shown an example of vulcanized rubber. This is the cross bond. See here how the rubber show vulcanized rubber show the cross band, and here this is the network structure. So here see the how the cross bands are there, different cross linking, sulfur generally adding to cross link the polymer chain, and therefore this is the elastomer, and generally sulfur is added to vulcanize the rubber. Fibers are also there. As we know, terylene, dacron, rayon are the fibers, and they have strong intermolecular forces, either hydrogen bonds or dipole-dipole interactions in the chain, and therefore this chain have high tensile strength, less elasticity, and high melting point. Example is the nylon and silk, and because of this type of fibers cannot strain like it is different from the elastomer. Elastomer have different properties, that is elastic properties, but fiber do not have such type of property because in elastomer have weak intermolecular forces. In fiber have high molecular intermolecular, strong intermolecular forces are there. And this is one example is shown how terylene obtained from the two monomer is shown here. So now we are discussing what is elastomer and what are the different aspects related to this elastomer. So elastomer is a polymer, and have we can say that have the elasticity and also have the some viscosity, and they can have the weak intermolecular forces, and it is a can be just look, that is the behave like a rubber. When we give the stress, it elongate, and we remove the stress, then what is then force, then it come back to the original state. So important feature of this elastomer is that generally elastomers are amorphous polymer and have glass transition temperature, and a considerable molecular reformation or the conformation is also there, and without breaking the covalent bond, it is a feasible. Because of the weak intermolecular bonds, it permits the polymer to stretch in response to microscopic stresses. These elastomers are generally thermosets, that is requiring vulcanization. Sometimes it may be also thermoplastic, and so this is very important material and having a number of applications of this material. Elastomers. Elastomers are generally saturated, unsaturated type, and saturated elastomer have some properties, and they show, or we can say that they are they have the superior stability as compared to against the oxygen, radiation, heat, or ozone. There is no more effect of this on the elastomer, saturated elastomer, and they are less reactive, and reactivity can be tested or can be determined by using some reactions also. So polyacrylic rubber, silicon rubber are example of saturated elastomer. Silicon rubber is shown here, how silicon get bind with this chain of the polymer. So is shown, this is the repeat unit which repeated and forming this type of silicon rubber. So this is the silicon rubber is a saturated elastomer. In case of unsaturated elastomer, they can be cured with the sulfur vulcanization process. An example is a butyl rubber. So here is shown, this is the butene shown is a repeat unit, and two types of monomers are there, and forming this is the N type, it is repeated. An example of this type is the butyl rubber. Polyisoprene are the unsaturated elastomer. They have less stability. So mainly two types are there of elastomers, and elastomer can also be classified based on sources, and therefore again now like polymers, elastomers also natural rubber, synthetic rubber are there, and as we know, Thailand is the major producer of natural rubber in the complete whole world. After that, Indonesia is there. There is a farmhouse of these trees of the rubber, and in India, Kerala is the leading state for this production of natural rubber, and we obtain latex from the tree. What is the rubber tree? Hevea brasiliensis. So this is the important tree from which the latex is collected, as shown in the here. picture, we have to cut the tree, and latex is collected here in this way. And this is the natural rubber latex. In case of natural rubber, monomer unit is the isoprene. And isoprene structure is shown here. This is the isoprene. And it also be exists in case of natural rubber. Two types of isomers are there, cis and trans. Cis 1,4 polyisoprene, and this is trans 1,4 polyisoprene. Only the arrangement is different. Cis, similar groups are on one side, and here is trans. And this is the important constituent of the natural rubber, isoprene. And conventional grade rubber shown here, three pictures are being shown. This is the sheet of rubber, smoked. This is the pale crisp, different color brown and blanket crisps are there. So these are the rubber sheet, and also we can give color by adding some pigment during the process. We can also make different types of colored sheet of the rubber. So one is a natural and second is a synthetic rubber. Synthetic rubber is a man-made rubber, that is SBR rubber, styrene butadiene rubber, and which can be synthesized in the laboratory, and we can improve the properties of the synthetic rubber. In short, also we can say that synthetic rubber is used as a substituent for the natural rubber in many cases, because they behave like they are better as compared to the sometimes natural rubber by improving their properties. And synthetic rubber can be hard like a bowling ball and soft like a sponge. So depending upon their properties, we can make the synthetic rubber as hard or as soft. So the properties of the synthetic rubber can be improved by adding some nanofillers, because some gaps are there in a polymer matrix can be occupied by these nanofillers, and therefore they give toughness, they improve the properties. And again, depending upon the amount, depending upon the pHR, how much we take of the nanofiller in the compound. So depending upon the quantity, composition, we can improve the properties of the synthetic rubber. And some example of synthetic rubbers are the BSR or SBR rubber, styrene butadiene rubber, and nitrile rubber, NBR, and chloropene rubbers are the examples which can be used to make the rubber bands, and these gasket, like that is the different types of articles. And as we know, styrene butadiene rubber is very difficult to synthesize, because butadiene, 1,3-butadiene is a very that is toxic chemical. We cannot we cannot open that cork. It is available generally in the cylinder, like a gas cylinder, and we can directly, we have from the cylinder to the reactor, we have to pass this, and then it is possible to synthesize as styrene butadiene rubber. So styrene is one component, and 1,3-butadiene. By mixing in proper proportion, we can synthesize this type of rubber, which is a synthetic rubber, can be synthesized in the laboratory, but we should have to take the care. This rubber or elastomer, see here the picture is shown. This elastomer or this rubber, synthetic rubber, can be used for different purposes. Mostly I have told just now that what is out of 100%, 65% of the rubber are used in a rubber industry for making the tires. Here is shown, this is the automobile sector. These rubber are mostly useful and for making the tires of different vehicles, two-wheelers or four-wheelers, or also even the tires of the aerospace. And here shown how the grids are there and side wall is there. This is the side wall, and this is the thread shown here. This is the thread of the tire. This is the side wall, and here this is shown here, the belt system, tire casting, and what is the bead. So in this way they made, and depending upon the properties, depending upon their material, this synthetic rubber can be used for this automobile industry. And now here, these are the different parts shown here. nut and bolt and different parts are there, which are also made by this rubber tubing is also there. And these also been used for biomedical sector, for surgical gloves, to protect from the virus or any other biological germs, or and to make the keep our fingers clean, or therefore we have to use such type of gloves. And rubber dam here is shown. Dentists also use sometime rubber dam. Uh, Mostly these are rubber is also useful for the making the sole of the shoes or uh, footwears. Different footwears have been shown, and nowadays such type of uh, uh, sleepwear, slippers, or like shoes, or these are made, footwears are made. And so these are the applications of this rubber material. We can make, this is the gray color, this is brownish, but now we can give color as we require. Just here is a green color. So it depends upon the pigment, which color pigment we are adding. And that is why it is possible to make different types of rubber sheets or rubber. And here in aerospace also, see here, this is the airplane, and shown different part of this material can be used. And synthetic rubber are mostly useful in this for making the different, for here the window and door shells have been shown. So here this is the useful material, and also for the tire of this aerospace can be made. So we found number of applications are there. Depending upon that, we can prepare the or we can synthesize. We have to synthesize the material, and to enhance the properties, we have to use different types of fillers. Nano fillers are there. In this material also useful in household sector. It is shown for gas tubing. This is here the rubber tube. This is another article. This is the pots. This is the toys can be used. So different material can be used, can be made by using such type of material. Advanced applications are also there nowadays. This material, synthetic rubbers, elastomers, can be used for making the robotics, used as actuators, and can be used as a diaphragms, artificial pacemaker. So as we know, lithium battery, where this material can also be used as a artificial heart. And this is the one of the part during the surgery can be used here. So these are the different types of field where we can use. As we know, nanomaterials are having versatile application in different field, different branches, different industry. What is now in the similar way, we can say that polymer is also a versatile material. And here, particularly the elastomer, rubber have lot of applications. And depending upon that, we have to synthesize or we have to prepare the materials. Why this rubber is show these type of different types of applications. So here is shown the elasticity. What is elastomers have elastic properties, or rubber also have elastic properties. How there is a changes are taking place. This slide shows the how the changes are taking place. So now here, as we know, rubber are coiled, shown here in the picture, and intertwined with the one another. See now, one rubber, second a long chain. So in this way, rubbers are coiled, okay, initially. But now when we use the stress, it become like this. So this is the coiled rubber molecule is now straight, make it a straight by giving the stretch. We can also, we know that, okay. Once we stretch, what is that? It look like this. See the stretches. Now there are two parts after stretching. When stress is removed, when stress is removed, then there are two parts. One is a below elastic limit, and this is beyond elastic limit. If below elastic limit, there is a limit. Up to that we can stress. So below elastic limit, then rubber come back or return back to this original, like this. Here is shown picture. But beyond the elastic limit, then it breaks, and what is rubber chains slide past each other. See here, this type of pieces, we can see that this type of things are there. So it is an elasticity. This is the material. There are two parts shown here, below elastic limit and after the elastic limit. So this because of that, and this properties here is after beyond the elastic limit, and here also below we can improve these properties by adding some nanofiller. That is the main part. And what is we can improve number of properties here. Now we know there are two types of rubber, natural and synthetic rubber or elastomer. And what are the advantages? What are the properties of natural rubber mainly and the synthetic rubber? So we can say that in case of natural rubber, there are the high tensile strength, also short tear strength, resistant to wear and abrasion and fatigue. It is also water repellent, and it also shows the resistance to alkali and weak acids. Now, what is synthetic? See now here, there are number of properties, more properties as compared to natural rubber. Synthetic rubbers are more useful because it is a solid and a flexible and also a durable. It can be molded as per the requirement by use of the heat, resistance to the heat, light and chemicals. Better, they also have the better abrasion resistance as compared to the natural rubber. Heat and aging resistance is also there. Flame retardant, so it also prevent the flame from the fire, any material. Resistant to grease or oil. So we can say comparing these two properties of this rubber, synthetic rubber have number of properties, more property as compared to natural rubber. Now, we have seen what are the different types and all the properties. What is now processing of the rubber composite? So in case of processing, important three parts are there, and three parts are mixing, and then compounding and vulcanization are the three important parts. In case of natural rubber, we can also call the India rubber. Initially produced consists of polymer organic compound, which is isoprene. So this is natural, but in case of artificial compound, artificial rubber compound, generally when we are going to synthesize, we have to perform these three parts. One is a mixing, second is a compounding, third is a vulcanization. Now to mix, we have to mix the component or the constituent in a proper proportion. So this table shows the composition of natural rubber composite. For this, we can use ingredient natural rubber in PHR. 50 means 1 PHR. So in PHR grams, okay, 100 milligram means 1 PHR. So here natural rubber is 100. It is taken in a PHR. So and carbon black is a nanofiller to enhance the properties, and it is the varying quantities. We can take carbon black, nano carbon black from 1 or 2 or 3 or 4. If we have to vary the proper amount of the carbon black, or we can also take the organo clay. Generally, the silica or clay can also be used, which is in a nano size, can be added in a rubber matrix to enhance the properties. And zinc oxide, we have to use some acylator, antioxidant, and also stabilizer. So stearic acid, 1. So this is the compound. Sulfur can also be added during the process. So this is the mixing. We have to mix all the ingredient, and then compounding is there. So 3 process you have to remember. These 3 processes are very important. Mixing first in proper different proportion, then compounding, and then vulcanization. So this is the one table shows the natural rubber composite. This is another nitrile rubber composite. We can take again now here carbon black filler. Here is shown carbon black. We can take carbon, what is the silica? We can take also another zinc oxide as a nanofiller. Tin oxide, antimony oxide, zinc oxide can also be used as a nanofiller, and we can improve the properties. So this is the mixing. So again, NBR, natural butadiene rubber here. Rubber we have to take the 100 PHR. Accelerator is now 2. Activator is there, zinc oxide, and stearic acid sometimes in small amount, and filler we have to use. After mixing all these, this mixture or this complete mixture we have to take it and we have to pour in a two-roll mill. Two-roll mill is the instrument where we can get the sheet of this material or rubber sheet. Now here is shown how the mixing of this compound is taking place and how the vulcanization are carried out. So in this case, we can say that after mixing all the component and before compounding, we should have to here use the we have to use the two-roll mill, and two-roll mill is shown here. In this case, two-roll means it contains the two-roll rod is there, and in this case, these two rods shown here, three pictures have been shown here. First is a two-roll mill machine, and how the two-roll works shown here, and after that compounding molding machine is shown. So in the first picture is shown two rolls. These two rolls are moving oppositely, and because of that the solution get press, and we have to apply also the hydraulic press. This hydraulic press applying on that is a 5 ton high hydraulic press we have to use for this making this type of rubber sheet. And in this case, here is a this picture shows this is the one rod, and another is here. Two rolls are there. They are moving in opposite way, and we have our solution, our mixture, we have to put here, and we have to start. Then what is the they immediately after pressure is so much that we get the rubber sheet here from this side, and we have to maintain temperature and all the settings. After that, immediately in a 1 minute we get the rubber sheet, which is the rough sheet, not finished sheet. So in this way, mixing of that is the cross-linking ingredient is also being carried out in two-roll mill. And for this case, we have to use the rubber and then activator as a zinc oxide or stearic acid, and then accelerator and cross linker, generally sulfur, can be added in this way. And then here how these two rolls, see, this is one and this is another. This roll is roll is moving, see here, in clockwise direction. This and the second one roll is moving in anti-clockwise, and we have to, this is the material or sample mixture. We have to take a container and we have to pour it here, see here, and this moving oppositely. So what is now, we get the rubber sheet here. So this is the clear picture is shown about the compounding of this by using this molding machine. So now here two-roll mill is we have to use to make the rubber sheet. And after making this sheet is obtained, which is rough in nature, and this is the mold compression molding machine. Here also we have to use the pressure, high pressure. So see, here is the this is the place and the for the sample or rubber to keep place the rubber sheet, rough sheet, and we have to apply this pressure here. We have to maintain the temperature 160 degree, and after 2-3 minutes after putting it here sheet, we get a very fine sheet, just like we have seen our sole, sometimes the rubber, very fine sheet we get after placing our compression in molding machine by applying the pressure, and at particular temperature we get a fine sheet. So this is the complete compounding. First we have to mix, then we have to mixture apply in a two-roll mill, then after this we get a rough sheet, and this rough sheet can be used here. We have to keep it in a compression molding machine, and in this machine we get the very fine sheet of different color as per our requirement. After that, next step is the vulcanization of this sheet or rubber. What is vulcanization? Vulcanization of this rubber can be carried out at 160 degree and corresponding to cure time using the compression molding machine. So here curing or cross-linking is a important part of the, and generally it is a this is the process uh, and carried out generally in a processing of the rubber in rubber technologies. This picture shows clearly how this blue color is nothing but the chemical crosslink. This is the blue color in the picture. This is the crosslink of the sulfur. It is due to of the sulfur because sulfur is added. Sometimes peroxide is added. Sometimes carbonate is added as a cross linker. So after adding in the rubber matrix, what is the, this is the cross linker, and because of that we get the network type of structure. So this is the picture which is show the physical cross link, and this is the entanglement is taking place. What is now when we processing is doing processing, when sulfur is added, they show this type of cross links. And so we can say that during the process of vulcanization, individual molecule of the rubber or this polymer are converted into three-dimensional network type of structure. So from one-dimensional or individual molecule is converted into the three-dimensional network. This is nothing but the polymer network or polymer chain, and which is contain the cross links. And this network structure is due to the vulcanization due to sulfur. And here picture shows physical crosslink and also show some chemical crosslink, that is the due to sulfur. So vulcanizations are crosslinks can be carried out by using some material like sulfur or peroxide or some other materials. And when we apply this material, macromolecule, rubber macromolecules are used for different purposes, like for this case, vulcanization agent like sulfur, peroxide, metal oxide, resins, quinone, and some other compounds are there which can be used as a cross linkers and which is added during the process of vulcanization. And number of cross links are there, and because of that they show some changes in the chemical structure. And vulcanization agents, temperature, and vulcanization time are the important to maintain the nature of that rubber matrix. So we can say that what are the benefits of this vulcanization of this rubber in the properties. So no doubt the properties of the rubber can be enhanced by the vulcanization. So they give good strength, tensile strength, extendability, excellent resistance to the, and also they show deforming load when it is removed, come back. So they show some low water absorption tendency, high resistance to the oxidation, wear, tear, and abrasion, and also show better good electrical insulator. So this is the, and that is why we make the hand gloves by using this rubber, which is the very good insulator. And as we know that electrician use generally gloves when they are working with this electricity. So this is made for that purpose also. These are the benefits of this vulcanized rubber. Now we can say there are now different types of vulcanized systems. And here this picture show one is a sulfur vulcanization system. And here is shown, here picture is clearly shows unvulcanized and vulcanized rubber network. So here is shown, see the network rubber molecules between the this sulfur in the vulcanized rubber is added. What is now, see, interactions are taking place. Rubber molecules between this sulfur and here this is the rubber. The interaction between these two taking place, and this is the unvulcanized. And after vulcanized, we get this type of network because we are adding the sulfur, and there is a sulfur crosslinks are there. So shown here, vulcanized network. So this is the dot. These are the dots where there is a crosslinks. So this is an important process, and there are different types of vulcanization system. First is the sulfur vulcanization systems. And now this system or this crosslink depends on the cross-linking which is taking place depends on the four important part. One is a sulfur dose. What is how much we are adding the sulfur? They show different properties. accelerator, which accelerator we are using, and how much amount also, and accelerator sulfur ratio. Both this ratio is also very important, and cure time. So cure time is also very important. So generally, this ratio accelerator we have to vary when we are vulcanize the rubber. So these are the some important part related to the vulcanized rubber system. Now, sulfur can also be sulfur QR system is a generally required unsaturated compound, and these are generally we can classify into three parts depending upon the cure time: conventional cure, efficient vulcanization cure, and semi-efficient vulcanization cure. Different types are there depending upon the dose of the sulfur or the curing time. There are three different types of the this vulcanized rubber, and here is shown this classification generally based on the ability of the system to combine sulfur dose donor, and there is a carbon sulfur carbon bondings are there because sulfur is introduced, and because of more strong carbon sulfur bonds, they show this type of cross-link density. And here this table shows the sulfur ratio are differentiating the fact. So sulfur and accelerator doses and accelerator are different. So depending upon that, depending upon the pH, how much pH we are taking sulfur. So conventional, here is some ranges of being shown, whether it is efficient, semi-efficient, or conventional. This is the conventional shown for this sulfur. What is the range, how accelerator and how the accelerator sulfur ratio we have to maintain, and efficient is this one, and for semi-efficient. So we can change the this amount of the sulfur accelerator and this ratio of sulfur accelerator, and we get different nature of and different types of properties, and generally it is shown the enhancement in the properties of the vulcanized rubber. There are some advantages also of different vulcanized systems. Here is shown some conventional, semi-conventional, and also conventional. So here different types of QS systems have been shown here: polymer, disulfide cross-link, monosulfide. Polymer is there, and we have to use this type of different types of reversion of resistance, or these are the tear resistance, heat buildup. So different types of, and whether it is low or high is shown here. It is been observed for particular rubber. We can observe this is the standard, and we can observe for our particular compound of the rubber vulcanized rubber system. Now, in addition to the sulfur, some other cross linker can also be used, and second important is a peroxide curing. And peroxide is used in many processes for to cure the elastomer. But important part is here that unlike sulfur, they do not need unsaturated bonds in the polymer chain. So this is the one important part. So peroxide does not need any unsaturated bond in the polymer, but sulfur needs unsaturation. So here is shown how this vulcanization of rubber compound via peroxide curing is taking place. So this is the rubber matrix, and here is alkoxide. This is the peroxide. Alkoxide can be used, and we get here alcohol, and this is the rubber chain. So this is the modified rubber can be used. Here is shown another example. So different types of peroxide can be used to modify the rubber, and here is the one process. So different types of cross-linking systems are there by using different curing agent. Now vulcanization of the rubber can also be carried out by radiation, by sulfur, by peroxide, and also by radiation. And these different types of radiation influence also the vulcanization process. And energy is satisfactory for generation of rubber macromolecule, and reactive forms of this radical is there. And also microwave energy, that is ultrasound, can cause the curing creation. So this curing of rubber can be carried out by different types of radiation, and free radical are formed during the process. And when rubber macromolecules are subjected to high energy rays, then X-ray at normal temperature and pressure causing the cross-linking of main chain to form three-dimensional network. And so this curing of the rubber can be carried out by using sulfur, or cross-linking is obtained by using the peroxide. By radiation also we get three-dimensional network, that is the so different types of cross-linker, different types of material used to make the rubber as a network type or cross-linker type or three-dimensional network type rubber we get after after vulcanization by sulfur, by vulcanization by peroxide, by vulcanization by using the different types of radiation. So many factors are responsible for this, and we get the three-dimensional network structure of the vulcanized rubber. Now during the vulcanization process, these are the part we can use. One is an accelerator, second is a active accelerator, then activator, then anti-degradant, antioxidant are used, and also we use a plasticizer, flame retardant can also be used, and different types of aspects are there. As we know, in case of and also plasticizers. So one by one, we will see what are the compound which can be used as a agent. So what is during the for the vulcanization, what is now vulcanizing agent is an important part. So in the vulcanization part, isolator just work like what is we can say catalyst. It generally enhance the rate of the vulcanization. So accelerator is an important, and different types of accelerators are being shown here. This table shows the available accelerators which contain the chemical groups aldehyde, amine, unidine, thiazole, thiophosphate are the examples which are group, and these are the speed. How they, if you are using aldehyde, amine, unidine, they show slow rate, and some fast delay action, ultra fast is also there. By using these are the accelerator which increases the rate of this vulcanization is shown here. Selection of accelerator for the rubber compounds is an important part, and in this case we can say that before going to select the any accelerator for a particular rubber product, we should have to know the properties of this accelerator. So good accelerator should contain all these other requirements for that, and here is shown what is the QA rate requirement is also important. Vulcanization method is also important. Maximum vulcanization temperature should also be available. Requirement, effectiveness of wide range of QA temperature, stability. So all these are the important aspect. No health hazards should be there, and no adverse effect on other properties should be there. So all these are the property we have to see regarding the use of this accelerator. Now there are some primary and secondary accelerators are there, and in case of primary, we can say that primary accelerator are used at 0.5 to 1.5 pHr doses in most rubber compounds. The basic accelerators such as guanidine, thiourea, and dithiocarbamate are used as a secondary accelerator to activate the primary accelerator. So structure we have been shown here, a primary and secondary. This is sulfonamide, and this is the thiazole, and this is sulfonamide, and the secondary are the guanidine, thiourea, and dithiocarbamate. So these are the examples where we can use these material as a primary accelerator or secondary accelerator. Secondary accelerator also used to accelerate the primary accelerator. So these are also very important in case of the compounding. Second important part is the activator. As we know what is activator here, activator is also important, and it is generally the organic or inorganic chemicals, and this prevent generally the chain from moving independently, allowing the material to stretch under stress and then return to the original shape. So when the stress is released. So this is activator is also very important part during the process of compounding here and vulcanization. Zinc oxide is generally used in combination with the fatty stearic acid. zinc oxide and stearic acid. We can also change the oxide, zinc oxide. We can also try for the aluminum antimony oxide with the stearic acid, like that. So zinc oxide and stearic acid is the generally used activator during the process of vulcanization in sulfur cured compounds. So magnesium oxide is also mainly used for vulcanization of neoprene type of elastomer. So different types of activators are there, and this is also important. It also perform important part in the curing rubber. So as we know, activator also we can say that in case of activator, which is also known as the vulcanization, causes the long polymer chain that rubber is composed of to become the crosslink. So activator added to convert into the crosslink. So what is so all these are the important part that is needed for vulcanization process. Another important part is the anti-degradant. So this anti-degradant is nothing but, we can say that these are all polymers or the product based on polymer are subject to degradation on exposure to the degradative environment like storage aging, oxygen, heat, UV light, like that. So it is especially used for white and light colored product, perform excellent in tire side wall. They have excellent thermal stability, anti-aging for polymers. It is an ingredient in rubber compounds. To determine the aging of rubber products, anti-degradant include antioxidant and also anti-ozonate, antioxidant and anti-ozonants. So catalytic degradation in presence of heavy metal ion can also be carried out. So anti-degradant is also very, it is depend upon the rubber or the degradation of that rubber during the different that is the field, and this is now there is a degradation of the rubber, but now this, when we use this material, then it prevent and convert into different types of degradations are there, and here is shown due to degradation due to storage of aging, aging due to heat, aging due to light and weathering, soluble metal ions, catalyzed by oxidation, and they show the what type of accelerating factors are there and degradation causes, and here is shown the types of failure. So aging, for example, surrounding condition, it depends upon the surrounding conditions. Degradation causes the oxygen, light, heat, humidity. These are the part, and because of that, loss of elasticity, tensile strength can be occurred in the rubber. So these are the failure, different types of, sometimes rapid loss is there, tensile strength release, that is the decrease of there. So some of the effects are there of this. So for that, we have to use anti oxidant or anti ozonants. So like that. So this table shows clearly. So what is the role of the anti-degradant? So we can say that this is the important part, and two are there. Anti-degradant includes antioxidant and anti-ozonants to protect the polymer from the degradation, and therefore this is very important for this purpose. And to also this is generally used in the concentration of 0.5 to 3.5 pHr. Depending upon that, we have to use the combination of antioxidant or anti-ozonants. Another part is there. What is the antioxidant? Are can be classed as a primary antioxidant, and also can be classed as a secondary antioxidant. Primary is due to chain terminating or free radical formation. It is due to the aromatic amines present in the compound. Secondary antioxidants are due to the peroxide decomposes the phosphides and thioesters. Some reactions have been shown here, how they are taking place. Mechanism of scavenging the oxy radicals shown here. So there is a breaking. So when it reacts with the acid, what is then this type of compound, there is a release of H, and we get this type of compound, and rubber get joined here. So this is the peroxide or secondary antioxidant decompose the hydroperoxide into the non-reactive product. So whenever we do this type of reaction, so see here, then it block rubber get joined, and hydroperoxides become non-reactive product. Generally, it decompose alkoxy group or hydroxyl radicals. Another general mechanism of peroxide composition is shown here. This is the acids, peroxides, and it releases, and we get ROH and this type of compounds. So antioxidants are used for this purpose, and mechanism also shown how the rubber can work, and antioxidant shows their nature in this case. Another more important part is the plasticizer we have to add in this rubber matrix. And as we know, oil and some other materials or the plasticizers are slippery, and therefore it is known as the plasticizer. And this plasticizer is necessary in rubber formulation for improving the processing of the rubber by lowering the compound viscosity, and also for aiding the low temperature flexibility of the formulated rubber. The advantages of these oils is that it is a powerful plasticizer, and in aging compounding during the compound process of the rubber, they are used to convert PVC, polyvinyl chloride, or the rigid plastic into soft, flexible, elastic material. So main aim of the plasticizer is to convert into or to get the soft and flexible or elastic material. So this plasticizers is also important during the process, and different types of plasticizers are there. Generally, oil are used as a plasticizer to convert rigid into soft and elastic material. Sometimes petroleum oil are also a source of plasticizer, can be used, and the activity these properties can be changed. So from rigid to elastic, from rigid to soft material. For this conversion, we are using plasticizer. Generally, oil is used. Plasticizer selection is also very important, and the plasticizer is added or can be added during the elastomer for various regions, and the regions are, as we know, to make the rubber soft, flexible, and lower the glass transition temperature, reducing the crystallization, increasing the dispersion, and lowering the cost of the compound. So because of that, this plasticizer is also very important in the elastomer. And an example of plasticizer generally used are the mineral oil, esters, phthalates, sebacates are the examples. And therefore, selection of this elastomer plasticizer is also very important part. And generally, plasticizer are mineral oil, natural products. Synthetic plasticizers are there. We have to add during the process. So to improve the properties, these are the three important types of plasticizers we have to use in the compounding of the vulcanized rubber. Another important part is the flame retardant property, and in this case, as this primary thermal, this is important because as we know, most of the hydrocarbons rubbers are flammable, or we can say combustible, and therefore flame retardant can be used or is the material. We have to refer to variety of these substances of rubber that are added to the combustible material to prevent a fire from the starting of to slow down the speed of the fire. So main aim is to prevent the material from the combustion. So different types of flame retardant compounds or material is added during the process, and main aim is to prevent. And so primary thermal temperature rise due to heating, primary chemical degradation start because of the free radical formation, and polymer decomposition also start because that is, we can say, thermal degradation, and decomposition start because of this combustion, and ignition can take place sometimes at a particular temperature. So to stop this combustion, what is the material is added, which is known as the flame retardant. And these are the factors which are used to prevent this fire. What is amount of flammable volatiles, free radical propagation, activation energy, decomposition temperature, oxygen level. All these are the important factors which are influence the flammability, and therefore we have to maintain proper ratio of these component, proper amount we have to use in the compounding of this rubber or elastomer. Another important part, that is, we have seen what are the different types of compounding and what are the different factors which are required for that. Examples also we have seen. Now, to enhance the properties, mechanical properties, environmental properties, thermal properties, and microscopic, what is now here, we should have to use the nanofiller like zinc oxide, silica, or clay can be used to reinforce the rubber. And for this reinforcement of the rubber, we need some nanofillers, and nanofillers should have some properties. Here is all our improvement is there. When we introduce the nanofiller in the rubber matrix or elastomer, they show the enhancement, they show the improvement in the mechanical and related properties, hardness, elongation at break, thermal properties, electrical properties, oil resistant, abrasion resistance, and also show some ozone resistance and aging resistance. So this is very important. Also show the swelling properties. As we know, by introduction of these properties, what is now, we can say that there is a improvement or enhancement in the tensile strength of the material. In case of tear resistance also, they show the improvement or increase of tear resistance. Tear resistance is a measure how the test of the specimen of the rubber show the growth of the growth when cut under the tension. It is also measured by the instrument used for the tensile strain and elongation. And abrasion resistant property is also there, which is an important part. And as you show some PHR rubber nanofiller composition also affect the addition of nanofiller in the rubber matrix. Then the weight loss of rubber is constant initially, but there is a weight loss after some time. And if we use the nanofiller, then this loss is stopped. And because of that, the abrasion resistance is very important, and each addition of this improve the this loss. So abrasion resistance is the ability of the material to resist the wearing due to constant with another surface, measuring the due to constant weight loss. Now these properties are they are different. So reinforcement the properties of the rubbers. So here next slide shows some points of each shown here. Clay or the carbon black or silica can be used as a filler to enhance the properties here in different amount, and we can change the properties. So as the compound this amount is changed, the properties, different types of mechanical, electrical, optical properties can be show the enhancement or changes. So we can use as a filler carbon black, and carbon black is the commonly used filler in a rubber industry. Now there are different types of fillers, and according to the color, black fillers are there, white fillers. Black filler means carbon black, and therefore it is also used as a pigment. White filler like silica, kaolin or calcium silicate, chalk, that is the face powder or chalk powder can also be used sometime. So these are the fillers we can use for this case, and according to that they show the effects. These fillers show some effect shown here, reinforcing and semi-reinforcing and non-reinforcing. So for reinforcing, precipitated silica can be used. So here particle size of the material of each one and comparison is shown. As the reinforcing effect increases, it increases as the particle size decreases, then reinforcing effect increases. So shown here, these are the part. This is the part where non-reinforcing is there, and here is a semi-reinforcing, and this is the reinforcing. Three parts are there, and different material used for this depending upon the particle size. So nanofiller generally used now to enhance the properties of this rubber, and based on that, this is the one important rubber. Carbon black is the rubber, and this carbon black is used as a filler and to enhance the properties of the rubber synthesized. So this is the important part, and this is the important component as a filler. Carbon black is mainly used to strengthen the rubber in the tire, but can also be act as a pigment because it is a black color, UV stabilizer, and also conductive and insulating the agent in variety of the rubber and plastics, and also show some coating applications. This carbon black filler are mainly used to in the rubber compounding to enhance the physical properties of the rubber composite. And so nanocarbon, that is the carbon black, is now available in nano size, and there are different methods to make this carbon black. Some of the methods are also being shown here, and these methods, by using these methods, it is possible to get carbon black thermal black process by using acetylene black process. These are the different lamp black process. If you take the lamp and keep it in a one part, what is on the upper part of the flame, what is now black, that is the it accumulates slow. Because of the slow combustion, we get the carbon after the 1 month. Okay, this is a slow combustion. Also, we get the carbon in nano size. This is one of the method of slow combustion of the flame lamp. Flame of the lamp is there. So different types of process are there, and these carbon black can be used as a nanofiller in different compounding process. And to main aim is to increase the properties of the rubber, and also it is added during the compounding of the rubber to increase the physical properties. We have seen number of properties have been enhanced by addition of carbon black. So if we use the carbon black as a filler, then they show there are some advantages and also some show the disadvantages. In case of advantages, it is a very good, we can say very excellent reinforcing properties material. It also increases the tensile strength. It also increases the modulus value. Excellent as a abrasion resistance. No cracking is there. It takes time for cracking. Dominating the filler in tire industry. And UV violet stabilizer can also be used for that. So improve the conductivity, electrical conductivity. So these are the important advantages, but at the same time, some disadvantages is also there. Poor dynamic properties shows agglomeration sometimes can take place. Obtain some renewable sources. Negative effects of carbon footprint may be there. Carcinogenic to human, to us, and higher rolling resistance. So slight disadvantages is also there, but majority are the advantages of this material. Another important nanofiller is a silica, and silica is the second important generally in the rubber industry. This material is used. Amorphous silica or carbon black. This amorphous silica work like a carbon black, and both these materials have been used to reinforce the filler, reinforcing agent or filler in the rubber industry for long times. Their presence in the rubber is essential to achieve the longer wearing products, increase the tire strength, and because of that they are adding tire strength also increases, and it is also decrease the greenhouse gas emission of the vehicles using these tires. So so it is very important to minimize the greenhouse gases because of this vehicle by using this such type of tire. Now silica is also very important filler, and can be used in the now already started the use of this nano silica is also available. Now, one more important part is there. What is the green tire? Silica silane system is there, and in this silica silane system, now in the Europe, important this green tire have been made, and this important tire, green tire, now already made in the Europe for this purpose. So because of that, here is shown green technology. As we know, green technology is beneficial to the society, and in this case is shown in the automotive industry, and here is shown this is the tire, and there are three parts shown. This is the wear resistance, and this one is the weight grip is there. Silica silane carbon black is introduced here, and what is now rolling resistance is there. And by using this green tire technology, what is now in the Europe, this type of tire have been made, and it is because it is synthesized, keeping in mind that lightness and aerodynamics, which are extremely necessary for having the strong grip on the road. This is the one point. And another is that green technology now can also be used for the tire of the car. And here, this show the improvement in the tire strength, cut chip, and having decreased the rolling resistance on the road, increases the abrasion resistance and weight traction, and also decrease the greenhouse gas emission. And therefore, this tire have been synthesized, in which silica particle is structure is shown here. Silica particle have been introduced as a nanofiller. By using this technology, what is this type of awesome tire have been already made, and now in future such type of tire may come in the market, and so they reduce the friction on the road, and keeping in mind that such type of tire are very useful. And here now, what is the main aim of this green tire of making? So here silica reinforcement is there in this tire, and the state of dispersion and interpressure interactions are very important, and that is shown here in the picture. Filler aggregates are here, and when adsorb the rubber chain in this way, and uniform dispersions are there. Initially aggregates are there, but now when we add the in the rubber chain, if we add the silica reinforcement, what is uniform dispersions are there, and because of that, the eco-friendly tire, which is made to reduce the fuel consumption, which is affected by the rolling resistance of the tire, and tire threads on the surface, it creates the friction, and the more friction, high is the fuel consumption. And because of that, this type of tire is very green tire, we can say. Green tire which is made in the Europe are very beneficial. So here question is there, how does green tire works? So here we can say that to reduce the fuel consumption, which is affected by the rolling resistance of tire and tire threads on the surface, it creates friction, and more friction, higher is the fuel consumption. And therefore, this green tire reduces the amount of friction created by their movement. In other words, we can say that the lower rolling resistance means that vehicle fitted with this type of tire consume much fuel while traveling. And because of that, this green tire, by using silica silane system, which is very useful, and it increases the this property by 8% more as compared to other, and reduce the rolling resistance. So that is why this is very important aspect. We can make such type of materials. Other fillers can also be used: calcium carbonate, kaolin clay. These also can be used for different application purposes. Studies of composite properties now here. So what are the different properties that we can study here? Is the mechanical properties to evaluate the tensile strength and other abrasion resistance, and tearing properties. Rheological property is also there to study the processing behavior. Thermal properties, dynamic mechanical analysis, dielectric study, antimicrobial properties, different resistant properties, morphology, different properties are there about these composite materials. Now here, rheological properties are there, and MDR, moving die rheometer, is a equipment can be used to analyze the QR characteristics of the rubber compounds. So here there is a pair of dies, and in this case we have to use for this rheological studies. And in case of rheological part, which is shown here, this is the EMDR, where we can measure this part, and reference standard is shown here. And in this case, to cure the rubber, so here is a introduction of the compounds. Here is the part where it is shown curing, and here is shown over curing. And after over curing, 3 parts are there. This is the matching, this is the plateau, and reversion. So all the possibilities are there, and by using this we can know the different aspect shown here. And in this case, different terminology which are used here: scorch time, TS1, TS2 can be shown here. This is the time of onset of curing, which is indicated as a TS. And from the graph, the minimum torque value can be known. And this torque is the measure of force acting on the object to change its rotational motion. So this is the measure, and by using MDR, it is the value measured by torque of the oscillating cycles. So minimum torque is there, maximum torque is there, optimum cure time is also there. So these are the terms we can use in this case. And this is the instrument here. We can mechanical, in case of mechanical, we can find out the tensile strength. Our rubber sheet can be cut into the dumbbell shape size. Say here is the dumbbell shape. After cutting in the dumbbell shape, we have to keep it here, one part, and here second, in this way. And there is a stress at particular part, and what is now this tensile strength can be measured by using this. And after that also the tear resistance stress and strain study we have to follow. So this is the UTM from this universal testing machine. We know this, all these are the part: tensile strength and modulus, elongation at break. So here is shown elongation at break. One part is here and second part is here. We have to elongate it. We have to elongate this this sheet of rubber, and one stage will come, it will break. It will become long and thread-like and become break. So that point is nothing but the elongation at break. We can measure with the help of same. And Young modulus stiffness can also be measured by UTM. So these are the instruments. to know the mechanical properties of this compound is there. Another important property, thermal properties. TGA is the method used to know the thermal stability of this rubber composite material, and some parameter we have to we can calculate in this case. Some parameter like that is temperature at which the maximum weight loss is taking place, on-set temperature, glass transition temperature, specific heat capacity, and also different parameter also possible. What is the activation energy from is obtained from the thermogram. Order of reaction can also be obtained from the thermogram by using some thermal methods. So these are the instrument is shown, but what is thermal property and thermal stability? Up to this material is thermally stable up to what temperature? That is the stability temperature of the material can be known by using this thermal TGA data. Now there is also effect of the this silane introduced in the rubber matrix in during the soldier process and in nitric rubber. So different types of rubbers are there, SBR, NBR. So they show the enhancement in the properties. And thermal stability, curing characteristic, morphology, mechanical, dynamic, mechanical analysis. Majority of the properties show some enhancement by the introduction of nanofiller in the polymer matrix. So here is next part is here is shown how the silane integrated sol gel show some effect, how they the reactions are taking place in a NBR nitrile rubber. So this is the one monomer, this is another, and polymer hydrolysis is taking place. We get this type of compound, hydroxides are there, and it get then condensation, and we get there is a removal of water, and what is we get this silanized silica structure is like this, and these are some parameters. So this type of chain is obtained, and this is a repeated. This is the repeating unit, and we get this NBR rubber. This is our work, and in case of rheological study, these are the some TIQ values have been shown, delta TIQ, Q time. All these are the data obtained. On the basis of that study, we can conclude that different types of stress and strain study is there, and this graph show enhancement in that properties. So this rheological study is very important because rheological tests have been used to observe the flow curve, that is the shear stress and viscosity curve, and dynamic yield stress plastic of viscosity. It describes the behavior of rubber under action of stress. So therefore, what is the behavior of the rubber under stress? This can be known by using this what is the rheological study, and these are the data is obtained for this rubber matrix. This is one method, what is known as the same, and also this is another method, same give the morphology of the material on the surface, and complete morphology on the surface and inside can be obtained from the TAME. So these are the very useful method to know the particle size and also to know the morphology of the material. So here is shown the morphology of some different types of material of the rubber, and the figure A shows the only the rubber morphology of the rubber, and in figure B shows the introduction of silica, the nature is changed, and in case of the this is the when we use 1 PHR. C shows when we use the 2 PHR silane, and this is the, so as we show changes the amount of the nanofiller silica show the different changes are there, have been shown here. So TAME, these are the TAME images, show some black colored silica particles. These are the silica particles dispersed over the whole part of that rubber matrix, and therefore we can say that presence of organosilane in this case, this confirm whether these are present or not can be confirmed from this morphology. So silica is shown in silane, and what is now different natures have been shown, and the morphology changes with the change of the nanofiller composition or amount. Raman spectroscopy is also very useful, and from that glass transition temperature and different transitions we obtain from the different peaks, and therefore in case of rubber, these properties are very useful. We are here in case of Raman spectroscopy. Here this is the spectra shown for SBR and the carbon black composite, and here the rubber which contains some asymmetric methylene or methyl stretching vibration can be known around the 2800 to 3000 centimeter inverse in the region. Carbon-carbon double bond stretching vibration of the rubber can also be obtained at around the 1666 centimeter inverse, and intensity of Raman peaks depends on the blend composition. So different peaks and characteristic signals is known from this Raman spectroscopy. So it is one of the powerful tool to characterize our rubber. In case now summary, as we have seen, different types of elastomer and the classification of elastomers, different types of applications of elastomer, and processing. First is the mixing, and then processing, and after that vulcanization and reinforcement of this rubber by using different nanofillers, evaluation of composite, and that is composites properties, rheological, mechanical, thermal, environmental properties are also there, curing properties are also there. Some examples and different types of example we have discussed in this part. So this is one of the field in polymer, that is a rubber, natural rubber, synthetic rubber we can use for this purpose, and this is one of the area anyone can do research in this part. Only we have to synthesize by using a emulsion polymerization method. We can also use to synthesize some synthetic elastomer, synthetic rubber or SBR rubber, and different methods, soldier methods is also there. So number of methods are there for synthesis, and also we have to change the composition. We have to change the composition of the nanofiller, and we because of that there are changes in the properties. And as we have seen one example of green tire, which is synthesized in the Europe to avoid or to it is beneficial to the society. So such type of tire now we need, and so there is an enhancement. There may be a now enhancement should be there in the properties of this rubber, and already rubber industry started the work on this, but now we can also introduce some nanofillers to enhance the properties of such type of natural or synthetic rubber. So once again, thank you for your kind attention. Now this is my research group, and on this topic, this one my student, that is the here is a Miss Rani Mankar, have carried out the work, and she has completed PhD and also get awarded this year, and her work was on the synthetic rubber. She has used the nanofiller, just I told, that is the carbon black and antimony oxide as a fillers, and after that important part is that she worked on this part, made the rubber sheet, and now published all the complete thesis in 9 research papers. So her thesis is completely published in elsewhere and also in Bentham Publishers. So this is an useful one of the area. That's why I have selected this topic. And here I stop here, and now thank you. If any questions or any doubts are there, you can discuss.
Sir, I have found one question in the chat box.
Okay.
I read it for you. Yeah. Just a minute, sir. Sir, there is one question from Dr. W.P. Badole. No, he wanted to ask you to share the presentation. I found one, yeah. Sanket Mathur, the participant want to ask you, sir, that Is Newtonian fluids at some extent can be considered as elastomers? Is Newtonian fluids at some extent can be considered as elastomers?
No, but
Is
what is
from
elastomer should have the properties like rubber. So that material should not have such type of properties.
Yeah, I think he got his answer. So thank you, sir. Thank you very much for such an informative, elaborative, and dynamic talk. And while moving toward the next part of this session, that is time to show gratitude to the eminent speaker. So to propose the vote of thanks, may I call upon Mr. Kailash More, Assistant Professor, Nabira Mahavidyalaya, Katol. Uh, Over to you, sir. Mr. Kailash More.
Yes, ma'am. Thank you, ma'am. Hello, I am audible?
Yes, sir, you're audible.
Hello. Yes, yes. Good afternoon, one and all. I would like to thank Dr. Vasudeva B. Gurnole sir from bottom of my heart for giving his valuable time and delivering us such a wonderful lecture on an overview of elastomers. Truly, sir, all participants surely got idea about what are the polymers, elastomers, rubber, and their processing, and what are their applications in the field of chemistry. I would also like to thank Dr. Nilesh V. Gandhare sir for a nice introduction of our guest speaker. I would like to thank Dr. Meshram ma'am for comparing the session. I would also like to thank Dr. Borkar sir, Mr. Jadhav sir, and all teaching and non-teaching staff. I would like to thank Dr. Adil sir, Mr. Revatkar sir for their technical support. Lastly, I would like to thank all the participants for participating and listening carefully with a great enthusiasm. With the permission of organizing committee, I would like to conclude here that today's session is over. We will meet tomorrow with our new guest speaker. Take care. Thank you, all of you.
Thank you, sir.
Thank you, sir. Thank you all.
Thank you,
We
sir.
take your
Thank you,
leave and
Gurnole
we
sir.
will meet tomorrow on same platform.
Thank you, Gurnole sir.
Yes, sir.
Okay, thank you.
Thank you, sir. Thank you.
Very nice session, sir. Thank you.
Thank you, sir.
Nice session.
It was long, no?
Sir, Sir,
No,
I
sir,
have
but
one
it was
question.
informative, and I think
Informative.
all the researchers will
Sir?
definitely benefited by your lecture.
Yes,
And
yes.
more of them show their interest in the chat box, that it is very informative, and they want that you share this PPT to us, that we can share it in the WhatsApp group. So if you can share with us, we will share the PPT in the WhatsApp group. And they all, many more, or I think all of them like your lecture, and they found it very informative regarding the polymers and elastomers. Thank you, sir.
Thank you.
Hello,
Thank
sir.
you, sir. Thank you, sir.
Thank you, sir. Thank you,
Hello,
sir.
sir.
More,
Hello.
sir, we can end the session. Please end the session.
Sir, I have one question. Can I ask a question, sir? Hello. Hello. I am audible?
More,
Sir,
sir,
you
it is
are
too late,
audible,
sir.
but
We can end the session, sir.
Okay, sir. Okay, sir.